Hello, this is Mr. Waterman, and this is Geometry Lesson 11.6, Areas of Regular Polygons. We're going to go back a little bit and work with regular polygons. A little terminology that you need. First of all, the center of a polygon. So if we inscribe a regular polygon into a circle, the center is the same as the center of a circle. And also a regular polygon, as opposed to any old plain old polygon, is one where all of the sides are congruent. So in this diagram we have a regular hexagon. Also recall that from the center to any vertex, that segment is called a radius. So right here, segment PN, for example, is a radius. And also an angle in the middle, like angle NPM, is called a central angle. So lastly, now we have a new term, which it sounds kind of funny. It's called the apothem. And no, I'm not speaking with a lisp. A-P-O-T-H-E-M. It's pronounced apothem. And that's defined as the distance from the center to the side of a regular polygon. So in our example diagram up here, we have segment PQ would be the apothem. So let me see if I can get a line on there. So that's segment PQ. Okay, so with that, we're going to pick up a formula for the area of a regular polygon on the next slide. First, let's go back and work a little bit with just regular polygons, not finding the area. Let's see if we can work with angle measures for a minute. So in extra example 1 here, we are asking, in the diagram, we have this polygon, looks like it's got 8 sides, so that would make it an octagon. Something's going horribly wrong here. Octagon. Let's see. There we go, octagon. And they've asked us, it's inscribed in a circle, C, so the center's C, and we need to find each angle measure that they've indicated here. So we want to find angle RCY. Well, they haven't given us any information at all to work with, except that it has 10 sides, or 8 sides rather. Do we know how to find, do we know how many degrees there are in a whole circle? Number of sides is 8. And if we go back and look at this, all the central angles in a circle added together are going to equal 360 degrees. Okay? So if I want to know what one central angle going between two of the vertices, so this angle RCY, for example, whoops, missed, RCY, is going to equal 1/8 of 360. So what I can do is I can take 360 divided by 8, and that's going to tell me exactly what I need to know. Okay, so 45 degrees. So RCY, measure of RCY is 45 degrees, so we can write that answer here. And now they're asking for the angle RCZ. Okay, so without going into too much detail here, this is the altitude of triangle RCY. And so that's meeting this side at a right angle. And since the two sides are congruent, RCY is going to be a perpendicular bisector of side RY. What that means is it's also an angle bisector of this central angle we just found. Okay, so RCZ is looking like 45 degrees times 1/2, right, which is 22.5 degrees. Lovely. 22 degrees. That's half of 45. And then finally they're asking us for angles Z, Y, C, Z, Y, C, and that is congruent to RCZ, so that is also 22.5 degrees. All right. Go ahead and watch part B of lesson 11.6.